In this short lesson, I want to show you how you can optimize two rectangles inside a boundary. So for example, this is the boundary using the Galapagos plugin. Here you can see that I can change the location of the first rectangle and the second one in the U and V direction, which I'm going to explain. Here is the addition of these two areas which we want to optimize. Also, we can change the size and X and Y of the rectangles, and as you can see here, when they intersect, the area is going to be 0. If the rectangle is outside, it's going to be 0. So Galapagos is going to find the optimized area here. We just double click the Galapagos, put it to maximize and increase the initial boost and run the solution. Okay, now if I stop the solver, you can see that this is the optimized results we have here. We can also play a little bit this manually. So if I move this around and make it a little bit bigger, so I can increase the area myself. But this algorithm helps you to find the optimized location and orientation of the rectangle inside a given boundary here. Okay, now let's take a look at the algorithm. First of all, as you can see here, we have the boundary, so you can just give any polyline or a singular curve for this one. Let's just say that we have this curve, and I'm going to give it here. What we're going to do is to find the bounding box of the curve, and then we're going to evaluate the surface with evaluate surface component, and we're going to move those points using a UV evaluation. After we have the frames or the planes, we can give that to a rectangle. To make the rectangles, I've used a technique here. For the rectangle, I've deconstructed the rectangle, and here we have a domain for the X and Y for the bounding box.